You're listening to the N2K Space Network.
Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes, host of the T-Minus Space Daily Podcast. Deep Space includes extended interviews and bonus content for a deeper look into some of the topics that we cover on our daily program. We talk a lot about the satellite market on our show, and we've noticed an interesting trend over the last few years with the growth of the low Earth orbit market. As systems get smaller and more powerful, it seems that many of the capabilities currently operating in geostationary orbit, or GEO, and medium Earth orbit, also known as MEO, will largely move towards the low Earth orbit, or LEO market, over the next 10 or 15 years. We spoke to Philip Harlow, the president of commercial satellite operator Telesat, about the market and military shift. Philip provided me with some of the context on Telesat's history and why they're excited about the LEO market.
We've been doing GEO for over 50 years. And so, as the GEO market has evolved, and with the introduction of first Ku band and then Ka band, that was certainly Ka band was touted to change the entire market. Telesat's been at the forefront of all of that. They're the fourth largest GEO satellite operator in the world, and have some very solid credibility. So, as the world evolves into, not into a LEO world, but more as LEO becomes an augmentation to those GEO capabilities, Telesat's at the forefront of that as well. We're doing things in a different way. So the whole concept around Lightspeed is not just to put up something which is standard internet access, best effort to everybody. We are focusing on the enterprise level part of the market. We are putting in place a number of features that we think are absolutely essential to succeed in those markets. And all of those elements from that high-end commercial market are very applicable to the government market, particularly the military market. And so we feel we're very well placed within our little ecosystem of LEOs to be one of the premier suppliers of LEO to U.S. government. And I'm very excited about the LEO market altogether.
Yeah, it is a very fascinating place that Telesat is at right now, especially since you mentioned it has such a great GEO heritage, and now it's also entering, or it is in the LEO market. It's a fascinating inflection point. And I would love if you could sort of set the scene for me a little bit. We talk about it a bit on the show, but I think it can't be emphasized enough how big of a change this is. And I'm curious, especially for government users, why is this move happening? Because GEO was sort of, the protective domain of especially the U.S. military, but now a lot of them are going into proliferated LEO. We hear a little bit about the why, but I would love for you to explain a bit about why this is such an advantageous move.
Well, you've pulled a number of threads there with one question, right? So let me try and unpack a couple of
Sure. I tend to do that.
When it comes to GEO, the military started using GEO, back in the 60s when they first launched TDRS and a couple of other of the satellites that they put up over the years. But in terms of technology and in terms of quantity, whenever we've gone into a conflict, and you can pick a conflict starting from the first Gulf War and moving forward, commercial has always played a huge part in the reach and capability that DoD has relied on. And they went on to build a fairly large WGS fleet in GEO. The design cycle for the technology that they've been using is 7 to 10 years. And I remember when the first WGS went up in around 2007 or thereabouts, that technology was kind of from the very early 2000s or maybe even the late 90s. And so there is a lag in technology that DoD has adopted. There are good reasons and bad reasons for that, right? So the bad reason is that DoD is not quite as agile as they might want to be, just given the rules that they have to play by. But there are good reasons for that as well. Certainly when in the military, when technology gets to the field, it's tried and tested, and they've got a supply chain, and everybody's trained. So it's a well-known function. What commercial brings to the ecosystem is this agility to bring these new things to the marketplace, to the user, where speeds are faster, technology is cheaper, terminals are smaller. So what we're able to do is get to those lower echelon users much more quickly than DoD can reach with its own technology and its own approach. That's not to say one is better or worse than the other. They're both part of the ecosystem. And one of the elements that we should talk about is what the SDA is doing in terms of its the tranche 1 and 2 of the transport layer, right? So SDA is experimenting with all of these LEO capabilities, and they're trying to figure out, like a lot of governments are, trying to figure out what is good, what's bad, what should we do, what shouldn't we do. My feeling is, like GEO, the LEO is going to take a long time to manifest itself and get to space. And probably by the time it gets there, there's going to be some lag in the technology. There's probably going to be some lag in the quantity that they're going to have. Because over time, not only does the commercial world change in terms of technology, but also what we're doing is we're building a growing ecosystem of users. So people who are using satellite today wouldn't have even contemplated that 10 years ago. Now, technology is cheaper, there's more capability, more people are jumping on to using this capability. And by the time the DoD gets to that point, we will have moved on and even more users will want to come in. What we found, I think, in Iraq and Afghanistan, and certainly what's going on in Ukraine today, the ability to have real-time access to video is changing the game, has changed the game even. And we see in Ukraine that there's a lot of exploitation of drones that they're able to control in real time beyond line of sight. And that's just what we've seen in the last 2 years. Imagine 5 years from now, 10 years from now, the users and the capabilities that we're going to be able to bring to bear with all of this new technology. So I think from a DoD perspective, they should experiment with this stuff. It's going to educate them a lot. So one of the important elements that been a lot of discussions over the years, but one of the important elements is when they build their own capability is to fully understand not only what they're doing, but what we're doing so that they can leverage both and not just ignore one or the other.
Yeah, I would imagine this is also why the spiral development model is something that SDA has put into place, because you want to be able to get those very current capabilities out the door, metaphorically speaking, as quickly as possible, right? Especially if that's what the commercial market is bringing to bear, so much faster than perhaps the really traditional development model.
Yeah, SDA is certainly pushing the boundaries of their comfort zone, of the DoD's comfort zone, but it's important, and they should continue to do it. Now, some of the things they do will fail, but some of them will also be successful. But I think success or failure is not determined necessarily by how well they do or whether it becomes an enduring capability, but really what do they learn from that? And one of the things that, if I can tell you a small vignette, and you can keep this or not, but it's up to you. But
I love a vignette, so go for it.
I was in the British Army. We were based out of Incirlik Air Force Base in Turkey. We were working with the Americans, the French, and the Turks, and we were patrolling the northern no-fly zone over Iraq. And we had Land Rovers, and the Americans had their Humvees. And for the Land Rovers, we have 2 technicians to maintain them. Whereas for the Humvees, the Americans had 5 or 6 or even 7. And so the one thing that they brought to the game was that they always had lots of stuff. It was really great. And they would lend us stuff and they would help us. But our 2 guys would do the same jobs on our Land Rovers, much simpler vehicles. But what we learned to do was to leverage each other as allies, but also to leverage the locals in terms of using that commercial capability. And it worked very well. And this was across multiple domains. And I just use that vignette as an illustration of how we can collaborate between allies, but also how we can collaborate with commercial. So that was my uniform days. And since I've come across to the States, I've been trying to engender that same sort of approach where we want to be real partners. We don't just want to be a vendor to DoD. We want to be partners. The majority of the people in our little segment of the industry are former military. Right? We want to be part of the solution. We don't just want to be some cheap vendor off to the side. So figuring out how we collaborate as partners, not just as vendor customer, I think is one of the important parts that flows out of what SDA is doing. So they are leveraging what commercial industry is doing for their own processes. I think the collaboration is pretty close. We just need to find a way to maintain that momentum.
We, on our show, because we work with our cybersecurity team over at the CyberWire, we're always very interested in talking about sort of the potential security risks and also resiliency of the networks that are being used. GPS spoofing is something that is a common attack that happens against GPS satellites, for example. LEO is going to have its own set of challenges. Resiliency is going to be a really important part of these networks. What are the resiliency discussions going on right now about how to harden a LEO network?
Well, I was talking with somebody just a couple of weeks ago, and a similar question came up, but the conversation was about the launch market. And the question was about whether LEO providers would want to insure or not insure their launches. And so it kind of ties in with what you're saying, because while that was focused on a different area, the fact is that when you launch LEOs, you're normally having multiple satellites on the launch vehicle, 14, 30, whatever the number happens to be. And if you've already got 1,000 satellites up in space, your tolerance for the risk of failure is a lot higher with the next launch, right? Because you've already got 1,000 satellites. If you're, as we are right now at Telesat, we have no satellites up in space. So those first couple of launches, we're going to be looking at very carefully in terms of our risk tolerance. And I think as more and more spacecraft get into space, I think the discussion about resiliency is going to ebb. So we're going to find that these networks, the way that we've designed the system, it's a self-healing mesh capability in space. You know, the inter-satellite links, the ISLs, have tremendous capability. And, you know, the initial system that we've got is designed such that you're going to have 3 or more spacecraft in view at any one time. And the terminals on the ground are going to be able to detect where there is a lack of signal or a degradation in signal. So we're going to be able to automatically move from one satellite to another where the path is better. So I think LEO has some inherent capabilities in terms of managing where that interference comes from, where it goes to, and managing the signal to avoid the pieces. It's an interesting dilemma, I think, that a number of people, particularly in the military, have, because the mindset is all about GEO. And now we're applying it to the LEO. And what I think we're missing is that the conversation is changing. We're still trying to apply some of the same standards from GEO onto the LEO market. And when you talk about all the elements of security in a satellite network, they're very different at LEO. So for a GEO, you've got a static terminal, you've got a static, for all intents and purposes, static satellite. So if you aim a jammer at a GEO satellite, it's going to impact the signal, right? You don't even have to be that close to the terminal on the ground. Whereas with a LEO, the orbital mechanics and the geometry of where the signal is from and to changes on a half-second by half-second basis. So while there is ability of adversaries to intercept those signals or to cause interference, there's an inbuilt mitigation already just by the fact that you're using LEO because of the mechanics, but also with the ability of that we have of changing from one visible satellite to another, you're able to avoid where you're experiencing interference of one spacecraft. Now you can avoid it and go to another. And there's a number of other techniques that we have that really make LEO resilient, especially the light speed version. There's a couple of other features that we have as well, which make LEO quite different than GEO. And we need to change the conversation when we're talking about about LEOs because it's definitely not the same. So as you move forward, I think there are a couple of RFPs out there that have been talking about satellite as a service, SATCOM as a service, or SATCOM as a managed service. And LEO really affords the ability to do that. Where GEO, you're typically partnering with different companies and you're having to work on multiple constellations. With LEOs, you are in a different ecosystem altogether. So not only are you able to control all of that within one control system, you're also able to tailor that for particular customer uses and figure out exactly what their customer is doing. So it's no longer, hey, this is kind of what we've got. The question is, what do you need? And let's figure out how to get it to you.
We'll be right back. Okay, I'm going to ask you a question about the future of LEO. And I know it's in a very interesting place right now, but I'm just very curious. We are in a fascinating time with LEO. You've covered a lot of really good ground about what's going on with LEO development now. If you had your crystal ball and you were looking ahead to 5 years from now, how much do you think things will change from this conversation? Where do you think things might be going?
So one of the key areas that we're all looking at, I think, with great interest is in what happens in the optical realm, right? So ground-to-space optical communications is going to afford us to put dramatically more capacity up in space that it'll overshadow what we have today by probably orders of magnitude. And so maybe not in 5 years, but certainly we're on the trajectory to identify how and when we make not the transition, but how we incorporate optical into our systems on the ground to space realm. The next thing that's going to happen is that all of the other LEOs that are in space are going to, not fleets, but the individual satellites like the radar sats of the world, are going to want to start getting their product back to their customers in real time. So there's going to be some connectivity solution between those independent satellites for Earth observation in particular to get their data back. So there's going to be space relay is the phrase that we're using. That's definitely coming down the road, and we're structuring what we're doing to accommodate that. And then, what the DoD is looking at is the future architecture where a terminal on the ground can move from one fleet to another, from GEO to LEO to MEO to HEO, in real time without having to have extensive work on the ground. So I think that's a little further away, just my personal estimation, but it is an aspiration from DoD in particular. I remember the movie Blade Runner, right, where you could go up to any terminal, the actor in the scene go up to any terminal and log in with his eyeballs and get access to as much information as he wanted. That's kind of the future that we are headed to. Whether we get there, we're not going to get there in 5 years, but
yeah, admittedly, it's a
yeah. How far we move down that road is up for question, right? How fast we move. The cyber realm is really, for me, the key element that we need to solve, and the adversaries that we're facing are sophisticated. They have a lot of resources, and in the absence of other means of attacking us, that's going to be a key battlefield. And so if I was to conclude and say, what am I most concerned about, it would be the cyber realm.
You're speaking my language. That is always something we talk about on the show, and I'm heartened in a way to hear you discussing that as well, because it's good to hear that getting more discussion because it is so important. So, Philip, thank you so much for sharing your time with me and your expertise. This has been extremely educational for me, so I really appreciate you speaking with me today. Thank you so much.
You're welcome.
That's it for our first T-Minus Deep Space for 2024. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Ivan. Our VP is Brandon Karp. And I'm Maria Varmazis. Thanks for listening. Have a great weekend.